Hey, AP Stats people, it's Mr. Ellinger here, and I had a request to go through the multiple choice questions here, so I'm going to do that for you. I tested the first one. I just wanted to click on it to see what happened, and I didn't think about it at all. I'm happy I got one wrong, so now I know what happens when I get something wrong. So, all right, so let's go through these. The first one is and I will admit I've gone through all the rest of the problems and I've written down my answers, but I haven't checked them to see if they're right. So we'll see how I do. First one, just a question of what's the population, what's the sample, what's the parameter of interest, what's the thing you're really interested in. The one thing you want to watch out for on this kind of thing is making sure that the parameter of interest isn't your statistic. Your statistic is what your sample result is. Your parameter, what you're really interested in, is what's the entire population, what's the correct number, the correct measure for them. You never know that unless you do a census, but you're hoping that the sampling gets you the answer there. So correct answer is C for number one. All right. And they give you a little description. I didn't see that. Okay. All right. We'll find out how I do. So I read this one. High school comment cards. Students who wish to make a comment can obtain and fill out a comment card and return to the front drop box in the front office. This is not a random sample. So the whole, it's informational, and it can be kind of like, oh, here's some information for you, but it's not useful from a statistical standpoint because it's not a random sample of the population. So, we can look at stuff, and say, this is evidence. No, it's not evidence. They shouldn't use the results because some students may not have filled out a comment card. That's true, but that's not the fundamental reason. So B is true, but not why they shouldn't use results. And that's the thing is and remember, we're not going to get multiple choice, so we don't need to freak out about that too much. And it would be a stratified sample if you randomly selected, but you didn't. And so best answer is D. It's a voluntary response sample, and so they shouldn't do anything with this stuff. Yay! Next one. Career department, administer a test, survey. 30, okay, they're going to do a sample. They're my sample methods, 30, 30, 30, 30. That's stratified. Submit it. Next one. Major League Baseball. Okay, what kind of sample is it? Okay, they're evaluating the timing of various events. They want to how long one mound visit, takes on average. So out of all the mound visits, so in theory you could time all the mound visits, but they're going to do a sample. They randomly select 100 games over the course of a season, got it, and records the length in seconds of every mound visit to that game. So they randomly pick a game, but then once they get a game, they take all the mound visits from that game, so they don't have to go find every single one. They can just look at 100 games. That's a cluster sample. So cluster sample, you randomly select which group. You have them divided into subgroups. You randomly select one group and look at everybody in that group. Do a census on that group, and you might do a few groups and do censuses on each one. But you and that's the difference between stratified, where you do something from every single group, but you randomly select through each one, as opposed to doing a census for just a few. So it's cluster. Cluster sample, the only purpose is that it's convenient. Stratified sample, it actually gives you a better estimate of the parameter because there's less variability in your results if you think that variable, the variable that it's grouped under, makes a difference in the results. Watching my time. So I'm going back to 3. If for this question, if there's going to be a big difference in how freshmen, sophomores, juniors, and seniors answer this question, then we want to make sure we're balanced on these. And so if we just did a simple random sample and just selected 120 students, then there'd be a lot of variability because one sample might have not all seniors probably, but it could be all seniors and one could be all freshmen. So you'd have a lot more variability if you did a simple random sample than a stratified, because this variable is so important in terms of helping giving information about how people are going to respond. That's how you justify why a stratified sample is important, is because that variable is important. I finished that one. Number 5, 20 volunteers selected for a trial. Volunteers were given low carb, low calorie diet. I didn't. Yeah. Oh, I missed this one when I read it the first time. I read it fast and I missed it the first time. Fortunately, I didn't click anything this time because I'm just noticed something. They randomly, they assigned a treatment, but they didn't have a control group. So you have nothing to compare it to. So all it's going to do is tell you for these volunteers how how they dropped. This is not an experiment. This is an observational study because there's no comparison. An uncontrolled experiment. All receivers. That's interesting. In our old book, I'd have to look in this book. In our old book, this would not be considered an experiment because you don't have comparison. The three essential elements of experiment was you have to have replication, you have to have control, and you have to have comparison. If you don't have anything to compare it to, then it's not giving you any information. I disagree with this one. I think personally, I think it's pretty small. I think it's not even an experiment, and I think different books would disagree about this one. Good topic to talk about, not a critical kind of thing. Just know you need comparison on this one, and I've never seen uncontrolled experiment show up as an expected response on an AP question in all the years of AP questions. It's never been something that anyone's supposed to write. Some books never even talk about uncontrolled experiment because it's an oxymoron. Experiments have to have control. All right, next one. DNR. What was my answer? Okay, DNR. Okay, so yeah, so they've got 100-foot plots and they're gonna have some breakwaters and some without. However, the east and west shorelines of this lake receive very different wave patterns. And so they suspect this will affect their responses. So they're trying to the explanatory variable is the use of breakwaters. And so some are going to get breakwaters, some are not going to get breakwaters. And the breakwaters are the explanatory variable that we're looking at. But we're concerned about this other variable, east and west shorelines, and they're going to be very different. And so we're going to treat each one as a separate group, and we're going to randomly assign breakwaters on the east side and some not, and randomly assign breakwaters on the west side and some not. And so as a result, this one is a blocked experiment. Ding! It's a blocked experiment, and so yeah, it's a blocked experiment. The blocks are east or west, and so when you do a block, you divide up the experiment into like sort of smaller experiments, and within each group, you assign half or an appropriate number with each treatment. I mean, I was going to say half with the treatment, half with the control, but remember sometimes you have multiple treatments, and so within each block you'd have to divide it up and assign a bunch of different treatments. Like when we had things like 3 different dosages for a medication, and on top of that a placebo group that didn't get any medicine. That's still a treatment, but it's a control. So this is a blocked experiment because we're randomly assigning breakwaters, but we're dividing the experiment, the population that we're working with in the beginning, into groups based on east and west because that variable is so important and we don't want to leave it to chance. This improves the results in the sense, never want to just say improves the results. It improves the results in the sense that that it's going to give you a better indication. You're going to be able to see any difference between breakwater or not much more easily because these two groups are being treated separately, and you're not having a situation where you might have a lot of east or a lot of west in one group or the other. All right, enough of that. 7, did I say? Okay, 7. 40 adult males volunteered, half got caffeine, other half took a placebo. During the workout, they measured the heart rate. The study found that those who took caffeine supplement had significantly higher average pulse rates during the workout. What conclusion can be drawn from the study? So the big thing here, it seems to me like, is what's the conclusion that you can make from the study? So one thing is, there's nothing saying that 20 is too small. There's nothing wrong with that. Remember, in a t-test, we'll be reviewing that, don't worry. In a t-test, you can have really small sample sizes as long as the population is normal, or if your data looks relatively symmetric, then you can say, oh, we can have a small sample size. So in this case, I'm looking at it and saying, yeah, that would be fine. There's nothing wrong with that. It said those that took caffeine supplement had a higher average heart rate, but it would not be correct to conclude that caffeine caused this to occur. That to me sounds like a situation where it could be one of two things. One is in a situation where it's an observational study, and so you can't do cause and effect based on that. And the other one thing that could happen is you could have those who took the caffeine supplement had a higher rate, but it's not high enough to make that conclusion. Where you fail to reject the null, and it's like, well, it was higher, but you can't conclude that the caffeine caused it because it's too close to being just random chance results. Both those are out because they did randomly assign the treatment, and so and some got the treatment and some got the control, and so it's definitely an experiment. And and the second part is that they said it's statistically significantly higher. So we're going to reject the null on this, and so that's why B's out. C, the caffeine supplements cause the heart rates to increase due to the placebo effect. What? That's not right. And then D, caffeine supplements will, on average, raise the heart rates of all adult males. Ooh, I see that. And I'm like, what? And these are volunteers. This is the big thing, is you can only apply something from a sample to the entire population if that sample is drawn from the entire population. So you haven't drawn a random sample of all adult males, or there's no reason to know that these people are representative. And so as a result, number 7, I like E better because it says it raises the heart rates of adult males similar to those in the study. So it only applies to this group. Maybe they're a specific age group or something, and other ages would respond differently. Maybe they're a certain race. One thing is that they're volunteers who are going to be working out. Maybe they're people who work out anyway. There's all kinds of things. So people like them, it's statistically significant. Caffeine supplements will do this, but people who aren't, then not. And so that's why the correct answer is E. Remember that multiple choice thing of catching the all adult males is not critical because it's not multiple choice, but you want to have that idea of random assignment of treatments. That gets you cause and effect. Random sampling, that gives you the ability to generalize to big populations. Ooh, 2.5 minutes, gotta go. Okay, this one I was specifically asked about. This says, so suppose you did a block design based on the size of the trucks, and then you had to find which one was impossible. So let's think about what this means. They take each block, so they take the mid-size, and half would get, it doesn't say, the first treatment. There's going to be 2 treatments, treatment 1 and treatment 2. Don't worry about context. So if we block this based on size, half of these would get the treatment, half of these would get the control, and then out of the full size, half would get the treatment, half would get the second treatment, I guess. We don't know if it's control or just a second treatment. And so I had to look through here and find one where it wasn't 50-50. These are all the people who got the first treatment, and so it should have been 2 out of this group and 2 out of this group. And I wrote, what did I write down here? Number 8. I wrote B. Colorado, Canyon, and Tacoma. 3 of these got the treatment according to this. Not possible. So that was B. That's what I thought. And yep, correct answer B. Okay. On this one, it was about testing a medication, and I only have a minute and a half left. Yeah, I'm gonna stop here so I don't rush it. We'll answer the 2 really well, and then we'll move on. So I'm gonna stop the video here, and there'll be a little more in a sec.